Welcome back to the another class, students. So in the previous we have learnt about types of muscle contraction and physiology of muscle contraction. Now we are going to see in physiology itself oxygen dissociation curve. It's also called as Bohr effect. What is this? We are going to see now. What is oxygen dissociation curve? You can see in the diagram. So the oxygen dissociation curve illustrates the relationship between the partial pressure of oxygen and the saturation of hemoglobin with oxygen. What does this curve relate? The relationship is between the partial pressure of oxygen and the saturation of hemoglobin with oxygen. Here you can see in the diagram. So it helps us understand how readily hemoglobin binds and releases oxygen depending upon the environment. Okay, how does it releases into the environment? So the curve is sigmoidal in shape. Here you can see the curve indicating the cooperative binding of oxygen to the hemoglobin. Here, this is the sigmoidal curve. Now, factors affecting oxygen dissociation curve. So, pH levels. Acidosis shifts the curve to the right, making it harder for hemoglobin to bind oxygen. Acidosis will result in shifting the curve to the right. Here you can see right shift and the left shift. Okay, in the right shift what happens? Decrease affinity for oxygen. Here you can see temperature, higher temperature shifts the curve to the right, prompting oxygen release in tissues. And also if you see here increased levels of this different, that means if you can see here in the diagram, increased affinity for oxygen and decreased affinity for oxygen. Okay, so here if you can see here, this is a sigmoid curve what I said, but this will shift to the right and left depending upon these. Okay, importance of oxygen dissociation curve in the lungs. How does it affect? So in the lungs the curve is shifted to the left, promoting oxygen binding to hemoglobin. Here you can see here in the diagram. In the lungs what happens? The sigmoid curve is shifted to the left, promoting oxygen binding to the hemoglobin. What will happen? This ensures efficient oxygen uptake in the lungs where oxygen levels are high. Then the high saturation of hemoglobin in the lung allows for optimal oxygen transport to the tissues. So this is happens. Next we are going to see importance of oxygen dissociation curve in the tissues. How does it help? In the tissues the curve shifts to the right. Here you can see slightly it shifts to the right. This enables oxygen delivery to the cells for metabolic processes. So the lower oxygen affinity of hemoglobin in tissues promotes oxygen unloading. This happens here. Next, some clinical implications of oxygen dissociation curve. You can see here, shifts in the curves can impact oxygen delivery to tissues in conditions like acidosis or hypoxemia. And also understanding the curve, what will happen, helps to managing the patients with any kind of respiratory or circulatory disorders. Role of hemoglobin in oxygen binding. So hemoglobin undergoes a conformational change upon oxygen binding. You can see here in the diagram deoxyhemoglobin and oxyhemoglobin. You can see the diagrams here. So here cooperative binding allows for increased oxygen affinity as more oxygen molecules bind. You can see here how the binding takes place. So hemoglobin's structure plays this is a quaternary structure, what you can see here, key role in its oxygen binding capacity. Here you can see the differences. So significance of cooperative binding in oxygen transport, we can see here now. Cooperative binding ensures efficient oxygen uptake in the lungs, and it also helps to enable the rapid oxygen release in tissues whenever it is needed and where it is needed. This dynamic process of binding and release of oxygen transport throughout the body is very, very essential in the respiratory and the circulatory systems. Next, we'll see some clinical applications of oxygen dissociation curve. If you can see, this curve can help access of oxygenation status in critically ill patients. When the patients are low, having that oxygen deficiency or low in oxygen, can be helped by this curve, by monitoring this curve. The curve is valuable tool in managing conditions affecting oxygen transport, and it also assists in so many oxygen therapy treatments or understanding the curve and adjusting the oxygen levels in the patients and all. Regulation of oxygen dissociation curve, you can see I told you earlier also, like pH, temperature will regulate and meet the curve of the metabolic demands. So the curve dynamically responds to the changes in the body's oxygen needs whenever it is required, either to the left or to the right. So finally, the oxygen dissociation curve is a fundamental concept in understanding the oxygen transport. This sigmoidal shape and regulation plays a crucial role in oxygen binding release. So anyone, that means by studying this sigmoid curve, healthcare providers can optimize the oxygen delivery and improve the patient's outcomes. So this is about oxygen dissociation curve. Please go through this video and make a note of it.